Hey guys, and welcome back to another video. For this video, I'll be going over classifying triangles. When I say classifying triangles, let's say, suppose I have this triangle here, and this triangle here. As you can see, they're both triangles, but they look different. So classifying triangles would help you understand the difference between these two and how you can identify them separately. So by the end of this video, you should hopefully be able to tell the difference between these two triangles and what their names would be called in more detailed terms. So the first way that triangles can be classified is by their angle measure. So an acute triangle is all angles are less than 90 degrees. Obtuse, one angle is larger than 90 degrees, and a right triangle, one angle is 90 degrees. Actually, it doesn't have to be only one, but it just has to be at least one. But obtuse is always going to be one. There's no chance it can be two angles that are 90 degrees. I think the same thing actually also applies for the right triangle. Only one's possible, but you get the gist of it. So 90 degrees just means it forms this sort of square, right? You see the square over here? Forms it. So, this is a 90 degree angle or right angle. You can call it any of them. So more than 90 would be anything out over here that goes this way. Less than 90 would be something like this, right? I'll draw different colors so it makes it easier for you to see. So more than 90 would be like this, red one, so instead it would be like this big, and then less than 90 would be something like this. It would be this big. So yeah, that is how you can tell. So now let's go over these picture examples. Obtuse, as you can see, a right triangle would be about over here. So you can see this is more, so that's why it's obtuse. Right triangle we already went over. And acute, a right angle would be about here, so you can see that this one is less because of this shaded area. Alright, now the second way to that triangles can be classified is by their side measures. All three sides are the same length means equilateral, only two sides are the same length means isosceles, and all sides are different lengths means scalene triangle. This picture has these lines, and if the lines are the same there's the same amount of lines, that means that the sides are equal. So equal means all three are equilateral means all three are the same. So excuse me, there are three lines, on each side there's one line, and since they're all the same number, that means all of them are equal. So this means it's equilateral. Isosceles, this may look equilateral, but since it only has two and not three, that means that it is an isosceles, regardless of what you think. If it has this, it can be sort of like a double checker to know if you're correct or not. And now scalene is you see 1, 2, 3, all different, meaning that sides are different lengths, right? So different, yeah, that's how you can tell it's scalene. Now these practice problems, before we do this practice problem, I'll do one with you before you guys pause the video and do this, so let's first read this. Classify each triangle by stating how it can be classified by its angle and then its sides. An example of the classified triangle could be a right isosceles triangle. Okay, so this would be angle, and this would be side. Alright, so I'll draw a triangle over here and we'll classify it together. So first off, let's go with the angles. Are there any right angles? Yes, we see one over here, meaning that it's a right triangle. But we also, remember, we also want its side. So how many sides are equal? So in the problems they give it to you, but let's just identify because some might not. These look the same, but then this one, well, in the right triangle, this is called the hypotenuse. The one that is not touching the right angle, and it's always larger. So a right triangle can never be, so right, well, how did that make it an arrow? I have no idea. It's okay. A right triangle can never be equilateral. Well, actually, the better rule is not the right can't be equilateral, but equilateral has to be acute. Okay? And I'll even provide you the reasoning behind this. So all angles in a triangle add up to 180 degrees. A triangle has 3 sides, and an equilateral triangle means they all have the same amount of sides. I mean, like, they're all the same. So 180 divided by 3, since they're all the same, they must have the same angle measure, equals that each of them are 60 degrees. So an equilateral triangle always has 60 degrees angle measures, and 60 degrees is less than 90 for each angle. So that's why it's always going to be acute. So some people, instead of saying acute equilateral triangle, or like they just say equilateral triangle, or they never say acute triangle, because acute does not have to be equilateral, but they do say just equilateral triangle, because equilateral means acute. But it's never wrong to like, you know, make your answer more justified by saying acute equilateral triangle. Now back to the problem. So we know that these two sides are equal, and this one's a little larger, so that means only 2 of them are the same, meaning right isosceles, I think that's how you spell it, triangle. Okay, now that you guys see how I did this problem, why don't you guys pause the video and try doing these 3. Okay, hopefully you pause the video and solve, because now I will be going over them. So, we see no right angles, so let's go ahead and pretend there was a right angle. So, 1 here, 1 here, and 1 here. So we see that it's a little less, it's like, not a little, but halfway less. A little less and a little less. So they're all less, meaning it's an acute. And we see that these sides are the same and this one's different. So that means isosceles, since 2 are the same. Isosceles. Triangle. Okay. Now I'll switch my pen color so you guys can tell. Okay, this one, we already see a right angle. Just remember, the sign always means a right angle. So, you know, it's a right. And once again, these 2 are equal and this one's not. And we got another isosceles that's like right isosceles triangle. Alright, and the final problem, let's put green. So let's look at the angle measures. A right angle would be about here. Here a right angle would be about here. And here a right angle would be about here. So big difference here. Small difference here, but still small. This angle and the actual triangle is smaller. Same here. So this one's an acute. And here we see our first not isosceles, because different meaning acute scalene. Triangle. And that'll be our answer. So I was thinking when I was creating this video that I should combine every single one, like try classifying triangles, classifying quadrilaterals and all that stuff, and just name the video classifying polygons. But I thought maybe it'd be easier for you guys to understand if I broke it up into separate groups so I could explain it more depth, like, you know, in more detail, and you guys could understand it better. So yeah, I thought this would be a good idea. Remember, once again, there will be a Google Forms in the video for you guys to submit. I've been getting quite a few submissions for my videos. Yeah, but you know, if they say the more the merrier. Remember, it's optional. There's no reason to make it mandatory. And of course, that even if I wanted to, I couldn't. But yeah, if you want to do it, you can do it. I always think it's better to get the more practice, so I thought I would leave it out there for you guys. And yeah, that's all for this video. Thanks for watching. Bye.